Hello and welcome. A little bit of further maths integration. A little bit harder than normal, but not too bad, this particular integral. The integral from 0 to 1, e to the r cos of x with respect to x. Okay, something like this. I mean, there's not a lot of things that come to mind when I'm faced with something like this. This is I can think of the r cos as some kind of angle. So I'm going to say, you know what? Let theta equal to the arc cos of x, and that will mean essentially x is the cos of theta, dx is minus sine theta d theta, and the limits 0 and 1 will map. When x is equal to 0, the arc cos of 0 is pi over 2. And the arc cos of 1 is actually equal to 0. So a lot of straightforward stuff is coming up. 0 goes to pi over 2. This will go to 0. And it's going to go e to the theta. Dx is minus sine theta d theta. And this, of course, will swap my limits, 0 to pi over 2, and that is going to give me the integral of e to the theta sine theta. And for those who do know me, this integral is one of the most hated integrals that I have. Is not because it's difficult, it's just a mess whichever way you do it. It's very, very ugly. And it does come up an awful lot in further maths and advanced maths. I wish I had a way of remembering the answer to that and just quote it, if I was a little bit younger, maybe I would invest a bit of time. That's how much I hate this one. This can be done by, of course, double integration by parts. It can be done by complex numbers. And the way I do it is by differentiation. E to the theta sine theta is, I'm going to differentiate. I just realized that I'm recording a video and I didn't turn the lights on. So I hope it's all visible so far. So this is one light coming on from one side and another light. So hopefully you can see this video better. So d by d theta, something which looks like that, comes from differentiating e to the theta and some kind of linear combination of sines and cosines. So let's say a sine theta for some capital A and capital B cos theta. And when you differentiate that as a product, you get e to the theta, a sine theta. I find this particular method a lot quicker. I don't know why. It may be, I'm actually foolish not to be using the more conventional methods. And now leave the e to the theta alone and differentiate this quantity. So that's going to go a cos minus b sine. And now equate, of course, pull out the e to the theta on the outside and equate sines and cosines. So a minus b, lots of sine theta, and this quantity here has to be 1 because, of course, we have one of them. And the cos is b plus a, so a plus b cos theta. And that means a minus b is equal to 1 and a plus b is equal to 0. A is the negative of b, so that's going to be a minus b is the same as a. So a, oops, I'm writing, I'm ahead of myself, sorry. A is equal to a half, and if a is equal to a half, then b is the negative of that. B is equal to minus a half. And the integral is done. So the integral is in fact e to the theta. The half, so let's remove the half at the front. And we have the positive is the sine one. So that's going to be sine theta minus cos theta, integrated between 0 and pi over 2. It's going to give us a nice exact answer, but nothing too difficult. So it's going to be a half let's write it on the next line, it's probably better. I have e to the pi over 2. Sine of pi over 2 is 1, cos is 0, so that's just that, minus, now we're putting 0. I have e to the 0 is 1, sine of 0 is 1, and then we got a minus cos of 0, which is 1. And of course, let's use a different color pen. This will go into a plus. And we can factorize it out. So it's going to be e to the pi over 2 plus 1. I hope it's the right answer there and I haven't made any mistake. It wasn't a difficult integral. It's just a little bit of further math. So I thought I'd do something a little bit more ordinary, a little bit more mundane than what I have been doing recently. Okay, I hope you enjoyed this particular integral. I'll see you real soon. Bye for now.